In the area of science and gigantic mysteries, the subject of what existed previously to the gigantic explosion has blended conversations and intrigued characters for quite a while. This huge request doesn't just test how we could decipher the universe, it challenges the genuine furthest limits of human knowledge. Imagine standing at the edge of existence, looking into the colossal shadowing and pondering what lay there before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. Anyway, was there a second earlier previously? Could there have been a condition of nothingness, a calm before the cosmic gathering started? And if this is true, was it? Or perhaps, was there something much more alarming that existed previously, before time itself? As we jump further into this question, science takes us on a journey past the universe's beginning point into thoughts that challenge our consciousness. Physicist Brian Cox, known for his investigation into the wonder of the universe, suggests that something surprising might have existed before the enormous detonation. He moves us to reconsider our thoughts on reality and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider secrets that might make sense of what existed preceding all that. We'll explore thoughts like self-important development, quantum changes, dark energy, and even multiverses. The answers we've revealed might just paralyze you, yet they could likewise open new understandings of our position in the universe. Get ready to jump deep into a world beyond imagination and science, where the obscure still winds around the shadows, leaving scientists floored and sometimes even upset. We ought to explore what existed before the Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we first need to painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, growing rapidly to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning, with galaxies spreading out this way and that from an early stage point. However, for what reason did this happen? Furthermore, was there a period before this thick, hot start? As indicated by the theory of enormous expansion, there was, without a doubt, an out of before, and it was not even close to void or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Anyway, this vacuum wasn't entirely unfilled. It contained a gigantic amount of energy that fueled the quick extension of space itself. This extension, called inflation, happened so rapidly that it essentially established the groundwork for all that would continue, a part of a subsequent space extending at unfathomable rates until the extension slowed down and the energy changed into matter particles and the forces we see as the Big Bang. But what was the nature of this energy? For what reason did it suddenly grow the universe, and why did it stop? Specialists believe that this inestimable expansion made patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly, with minuscule air pockets forming here and there, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our understanding of the very universe itself and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real. At any rate, as per our current understanding, regardless of whether you eliminate all energy, particles, and radiation from the universe, it would still not be genuinely void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable embroidered artwork of something, even in its most vacant structure. Regardless of whether we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally nothing in it, no particles, no radiation, and no energy, except quantum fields and major constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a peculiarity called zero-point energy, which represents the least possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a spooky resonance of movement, even in what should be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe, while inflation continues in different areas, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe might actually make its own Big Bang. Every universe exists as a separate, independent domain, unaffected by the others because of the rapid expansion of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? How we may interpret nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, momentarily acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This constant movement in what should be. The presence of dark energy suggests that, regardless of how far back we go, some form of energy may have always existed, shaping the conditions that led to the birth of our universe. If dark energy or a similar force was present before the Big Bang, it could mean that our universe is just a phase in an ongoing, endless cycle of creation and destruction. One of the most fascinating possibilities emerging from modern cosmology is the idea of cyclic universes. According to this theory, our universe may not have emerged from absolute nothingness but rather from the remains of a previous universe. In this scenario, the Big Bang was not the beginning of everything but just a transformation, an event in an eternal cosmic rhythm. The cyclic universe model suggests that the universe goes through repeated phases of expansion and contraction. After billions of years of expansion, it could eventually slow down, collapse back into a singular state, and then undergo another Big Bang, starting the cycle anew. If this is the case, then, before our Big Bang, there might have been another universe, one that collapsed and gave birth to ours. This idea aligns with some interpretations of string theory, where extra dimensions of space could play a role in a continuous cycle of cosmic rebirths. Some scientists propose that our universe may have collided with another in a higher dimensional space, triggering the Big Bang. If this is true, then what existed before our universe could have been an entirely different cosmos with its own laws of physics. Furthermore, the concept of the quantum vacuum suggests that even nothing is unstable. Quantum mechanics indicates that empty space is not truly empty but rather a sea of fluctuating energy fields. These fields can randomly generate particles and even entire universes. If our universe emerged from a quantum fluctuation, then the very notion of before becomes irrelevant. Universes could constantly be appearing and disappearing in an infinite, self-sustaining process. This leads us to a profound question. Is there ever a true beginning, or has existence always been? If time itself emerged from the Big Bang, then asking what came before might be meaningless. Just as there is no north beyond the North Pole, there might be no before beyond the Big Bang. Only a timeless reality where universes arise and dissolve endlessly. While these ideas remain speculative, they push the boundaries of human understanding. They challenge us to rethink our concept of time, space, and existence itself. As we continue to explore the mysteries of the cosmos, We may one day uncover evidence that sheds light on what existed before the Big Bang, or perhaps we'll discover that the question itself is the key to an even greater mystery. One thing is certain: the universe is far more complex and fascinating than we ever imagined, and the quest to understand it is only just beginning. If our universe was devoid of all matter and radioactivity, this force would persist. To improve the structure of spacetime in this way, a troubling question emerges. If dark energy existed prior to the Big Bang, could it have formed the factors that contributed to the birth of our universe? It's possible that dark energy is the unnoticed creator of inflation, or even the actual moment when our universe began. As we investigate this possibility, we face the potential of dark energy as more than just an influence on our universe, but as a key that could provide access to the multiverse as a whole. Another theory that offers a replacement for the Big Bang is cyclic cosmology, the idea that the universe goes through innumerable cycles of birth, death, and rebirth. In this model, the Big Bang is not a single event, but rather a component of a timeless rhythm in which universes expand, collapse, and regenerate. This theory suggests that the universe we live in may have been reborn from the ashes of a previous existence. The expansion and contraction of the universe in a cyclical pattern would entail that there was never a true beginning, but rather an endless series of universes growing and changing in a repetitive cycle. The study of cosmology raises significant questions concerning the notion that time itself may be cyclical, as opposed to linear. If this theory is correct, it could indicate that the preceding Big Bang was merely another version of the same event, giving birth to the universe we have today. Researchers argue that this theory provides an answer to the question of origins, claiming that the universe has always existed in some form, beyond our conventional understanding of time and existence. Gravitational waves are another intriguing concept that may provide clues about what existed prior to the Big Bang. These waves are fluctuations in spacetime caused by massive cosmic events. Scientific theories suggest that if primordial gravitational waves were ever found, they might reveal new insights into the universe's earliest moments. If detected, these waves could serve as remnants of a pre-Big Bang universe, offering tangible evidence of what came before our own. The possibility of discovering such waves is one of the most exciting prospects in modern cosmology. Not only could they expose the truth about the Big Bang, but they might also provide a glimpse into the state of the universe before its birth. Investigating these ideas pushes the limits of our understanding, challenging even our most fundamental assumptions about space, time, and existence. One of the most mind-boggling ideas comes from the study of quantum gravity, which seeks to merge general relativity and quantum mechanics. This merger could reveal a unified theory of everything and offer insights into what existed before the quantum Big Bang. According to quantum gravity, time and space are not continuous, smooth entities as we perceive them. Instead, they may be composed of hidden, granular structures. This theory suggests that the fabric of spacetime itself could have originated from microscopic quantum fluctuations at the Planck scale, shaping the universe in ways we do not yet fully understand. From this perspective, what we perceive as the smooth spacetime continuum may have emerged from these shifting quantum fields. It is possible that time itself only arose from these quantum processes, meaning that describing the Big Bang as the beginning may not be entirely accurate. Instead, reality before the Big Bang could have been governed by an entirely different concept of existence, where time and space were incomplete or undefined. Another fascinating possibility is that our universe is just one of many within a vast cosmic landscape, each with distinct physical properties. This idea, rooted in string theory, proposes that all fundamental particles are actually tiny vibrating strings. The string landscape suggests that different configurations of these strings give rise to different sets of physical laws, implying that our universe is just one of many emerging from its own unique Big Bang-like event. If this theory holds true, other universes might exist with varying gravitational strengths, dimensions, or even entirely different forms of matter. In this view, our universe is not unique, but rather part of a grand multiverse, where each universe independently develops. The multiverse theory presents a compelling alternative to the idea of a singular Big Bang, suggesting instead that another universe could have preceded our own, leading to endless cycles of creation and destruction. Physicists have also explored the role of black holes in shaping the cosmos. One hypothesis gaining attention is that our universe might have emerged from a black hole in an alternate universe. According to this theory, the singularity at a black hole center, where spacetime curves infinitely, could be a portal to a new universe. If true, This could mean that our own Big Bang was simply the birth of a universe from the remnants of a long-dead black hole. Investigating these concepts requires a deep re-examination of time itself. Some cosmologists argue that time, as we understand it, may not have existed before the Big Bang. If time emerged from quantum fluctuations or an initial timeless state, the question of what came before might be meaningless. This challenges the conventional notion of causality, which assumes that events unfold in a linear sequence. If time did not exist before the Big Bang, then asking what preceded it may be an illogical question. Cyclic cosmology, as previously mentioned, offers another perspective. This model suggests that the universe undergoes endless cycles of birth, expansion, and eventual collapse. Each Big Bang could simply mark the latest phase in an eternal sequence of cosmic cycles. While each cycle might differ in certain ways, the overall process would have no true beginning or end. In this view, the question of what existed before the Big Bang becomes irrelevant, as the universe has always been in motion. Another approach to understanding the pre-Big Bang universe involves considering a primordial cosmic state, a dense, high-energy soup of elementary particles, including quarks, leptons, and bosons. Some versions of this theory suggest that this primordial state existed in a quantum foam-like environment, where particles continuously appeared and disappeared due to the uncertainty principle of quantum mechanics. If true, the properties of this early cosmic soup could offer valuable insights into the origins of our universe and what might have come before. Understanding the universe before the Big Bang remains one of the greatest scientific mysteries. As advancements in quantum cosmology and fundamental physics continue, new hypotheses will emerge, offering increasingly complex and sometimes paradoxical explanations of our universe's past. While we may never fully comprehend what existed before the Big Bang, the quest for this knowledge will persist, pushing the boundaries of human curiosity and inspiring us to explore the unknown frontiers of existence.